Welcome to the Tool Shed. My name is Mark, and I am a tool. You laughed, but you're also in the Tool Shed, so what does it say about you? Just kidding. Sorry, I'm not usually that mean. That's all. I'm kidding about that, too. A little bit about me, just very briefly. I got my start in information security when I was the team lead of information security at Medline Industries. If you've never heard of Medline, the next time you're at the doctor's office or, God forbid, in the ER, just take a look around. Probably half the products there will have a Medline logo on them. I was an IT there for several years before I became the IT security team lead. I left there and I became a sales engineer at LightCyber, which was a UEBA. They were bought by Palo Alto Networks. I did a couple of years at Palo Alto Networks, and then I left there to come to Corelight because I believed in the open source mission of Zeek, which was the primary open source tool. Ooh, got hot there. Primary open source tool underpinning the sensors. And community-wise, for the past few years, I've been helping run CTFs at B-Sides Kansas City, which I really enjoy getting out there. I'm actually in the Chicagoland area, so it's a fun time for me to travel out there. And also for the past few years, I've been a threat hunter in the Black Hat Conference Network Operations Center. So I've been to 7 Black Hats since the spring of 2023. That's a lot of miles, let me tell you. So I'm here to advocate for the idea of network security monitoring. That's what the process of looking at packets to see if there's things on your network that are interesting used to be called. That term was primarily championed by Richard Baitlick. He wrote a couple of books about it. You've probably heard of them or seen them, and I highly recommend those. In the past few years, though, we've decided to call it network detection and response instead, right? This is to align it with the concept of EDR, endpoint detection and response, but instead doing the same sorts of things that you do on an endpoint, like alerting on things that might be suspicious or malicious, and also documenting what's happening from an agnostic point of view so that you have it for incident response. NDR is to the network what EDR is to the endpoint, right? Same sort of thing, alerting and documenting. So it's just a rebrand of that term of NSM. So in practice, the two tools that I think are the most important for doing this are Zeek and Suricata, right? Probably most people have heard of Suricata before. It's a fork of the Snort project. It was a fork of the Snort project to make it multi-threaded. You know, only 10 years before Snort actually got around to making it themselves multi-threaded. So that's a pattern matching IDS, right? You give it traffic and you give it signatures, and it tells you if any of the traffic matches any of the signatures, and those signatures are usually built around alerting on this looks like command and control, this looks like exploit, things like that. Zeek, on the other hand, is built around disassembling packets and reassembling sessions and then documenting what those were. So saying this was a connection to this destination and it was SSH and here was the client string and here was the server string. Or this was an HTTP session, it was a GET, this was the URI, this was the host, and this was a snippet of the post body, this was the user agent, things like that. And it's very incident response focused. And the reason I advocate for using both is there's a problem with the network intrusion detection if that's your only approach, if the NIDS only approach, I call it. If you're only using something like Snort or Suricata to look at traffic and get alerts, you can get alerts, but then you can't really truly effectively investigate them without additional data. So here's an alert. It says it's ET, right, emerging threats, malware, 999 rat check-in. And we have a translation of the signature here that says that it looks for HTTP traffic leaving the network. It's a GET, URI contains /999. So if you see something like this in your environment, right, you get an alert for that, and then you see a connection, you look at the HTTP log, and you see it was a transaction leaving my network, it was a GET request, and the URI ended in /999, then you would say, yes, that machine is infected. But you could be wrong, right? Having telemetry allows you to zoom out and say, what other HTTP requests, do I see any other HTTP requests from that origin to that destination or to other destinations that have similar characteristics? And in this case, if we zoom out, we can see that to that same server, that HTTP client made lots of other requests for like 971 and 972 and 985 and 99 bill. And at that point, you can say, well, the hypothesis that it's infected is probably wrong. Probably what's happening here is this is like somebody crawling looking for URLs, right? So if you were going to take that machine and nuke based on the fact that you thought it was infected, you could be wrong. And that's why I advocate for that. So if you want to get network telemetry, there's a handful of ways that people talk about doing this. One is NetFlow, right? We like to say the network is the sensor. You don't have any new equipment deployed. You just sort of turn it on switches, enterprise switches and routers that are already out there. It's lightweight, it's easy to store and to search, compresses easily, all these things are good, but it has some severe cons, like it typically lacks protocol level visibility, and even to the places where it has some protocol level visibility, it's usually missing, it's a small handful of protocols, it's not very comprehensive. Flow generation is a low priority on switches and routers. It's not guaranteed, right? So if a switch and router has to decide between switching and routing your packets or giving you NetFlow, it's going to choose switching and routing the packets if it's making a sane decision, right? And it's often sampled as well. So you might be able to answer questions like, was there a connect, like I saw a connection to this thing, you could say, if it's in the logs, there was a connection. But if there wasn't a log, you can't say that there wasn't a connection, because there might have been a connection that wasn't sampled, right? And then you didn't get a log for it. So this is how I illustrate the main problem with NetFlow, is that if I gave you these two records that have a source IP, source port, destination IP, destination port, maybe a number of bytes going in each direction, and I told you that one of those is SSH and the other is SSL, could you tell the difference with a NetFlow record? If anyone came up with the answer that wasn't no, I think you're wrong. So what people often do then is they say, well, to get around that, I'm just going to store PCAPs. Right? And the great thing about PCAPs is they're comprehensive. And the second great thing about PCAPs is they're comprehensive. And would you believe that PCAPs are comprehensive? This is a great illustration of just how comprehensive PCAPs are. They are really extremely comprehensive, which makes them memory intensive to search and to index. It makes them heavy to store, all of that, right? The main problem with PCAP is that when you try to open up a week's worth of PCAPs in Wireshark, this is what happens, right? Anybody try to do it and live to tell? No. And the other problem is you need some small portion of those PCAPs. How do you find them, right? Especially if you have a week's worth of PCAPs or a month's worth of PCAPs or something like that. So Zeek is the sweet spot. You pass in PCAPs, what you get out the other end are logs that are like 1/100th the size or less of the traffic that you fed in. It's text, it's searchable, it's greppable, it's storable, it's compressible, all of those things. It's built for humans, right? So back to our earlier example, we got those two records, but now you get a field that says the service. And one says SSH and the other says SSL. So you can quickly find, do I have SSH leaving my network on port 443? That's a query away in anywhere that you store that data. And then even more than that, that was the con record, the connection record, which is just describing the connection. But you also have this notion of a UID, or a unique identifier, for that session, and that links to any other logs that are related to that. So in this case, we have on the left the con record for the SSH, and on the right we have the SSH entry for the SSH log for that, which has SSH-specific details, like the number of authentication attempts that there were, and the server string that was just reported. And if the client had actually continued the SSH session, then they would also report a string, and we would have that here as well. So this is an indication that the client connected, got the server banner, and then just said goodbye and left. And you can do this for lots of different protocols. For instance, HTTP, you would get things like the host that the client asked for, the status code returned from the server, what was the type of data that was returned from the server. In this case, it was HTML. What was the user agent that the client used? What was the URI that they accessed? In this case, it was a post. What was the post body? Here's a snippet of that. And you can see like Windows service and process names in there. And that would be a pretty strong indication that something is leaving your network that you don't want to be. You can do it for other things as well, like DNS. Here we have the query, what domain was asked for, what did the server respond with, what were the answers that they got back, what was the TTL, and what was the round trip time for that transaction. So there's a lot of information there as well. And for many different protocols. So I really encourage you to look at Zeek if you haven't before. Scott Runnels was very kind in publicly talking about when they were doing the SolarWinds incident response and investigation, like they were using Zeek, and said it was instrumental in finding it and investigating what was going on. And Rob Joyce, I always like to point out, he's the former chief of the TAO, Tailored Access Operations, right? So this is a government group that's tasked with essentially infiltrating networks to gather intelligence for the U.S. government. And he gave a Usenix talk in 2016 where he said, as an offensive person who's breaking into networks, the one thing he's afraid of is somebody logging what's happening on their network, right? And the way you do that is with Zeek. So you can do things like show me all the DNS queries that go to the .info TLD and how many clients are asking for them. Like you can ask, when you have data, you can ask questions and get data-driven responses. And so I want to get into using some Zeek. So let's go over here to a terminal. And I want to get out of that and clear it and make it bigger and then probably zoom in a little bit because I think make it a little easier for everybody to see. So there's a handful of ways to get Zeek, and you can find them at zeek.org. You can download packages that are already precompiled for Linux distributions. You can download source, and you can compile yourself. This is always a thing you can do. If you just want to play with it, you can get it. There's a Docker container, Zeek, published under the Zeek brand. So it's Zeek/Zeek is the Docker container. And it's also embedded in things like the Brim ZUI, Z-U-I, or whatever that's called. I'm never sure how to pronounce it, if it's ZUI or Z-U-I, but I'll show that in a second here too. So what I'm going to do today is I have a directory here. It's got a couple of PCAPs, and I'm going to drop into a Docker container. So Docker run, can't type and talk at the same time. It's always dangerous. And I'm going to map in a volume, right? So I'm going to map the current directory in as /PCAPs, for example. And I'm going to run the Zeek container, and I want to drop into a bash shell. This will get me into the container where we can start to work. Like this already has Zeek installed, and one of the ways that you can use Zeek is to just run it against a PCAP at the command line. So if we want to do that, what we can do is Zeek, and we can read one of these PCAPs. So I know, I have to cd into the directory, of course. Zeek and read this PCAP, and we'll read that one, and that is it. It's going to spend maybe 10 to 20 seconds processing this PCAP. It's going through it. I didn't show it, but this PCAP is it's somewhere between 700 and 900 megabytes in size, right? So 20 seconds processing time, I think, is very reasonable for us to get through this. It's probably a few days worth of traffic for a couple of machines. And now what we have in the directory is we have our PCAPs, but we also have all these logs, right? Analyzer.log, con.log, DNS.log, and so on and so forth. And these are the meat of what you get out. So con.log is the connection log. It has all the connections in it. And then DNS log has all the DNS transactions. And then files.log has information about any files that were observed. HTTP.log has information about HTTP transactions that were seen. OCSP for the OCSP protocol, PE for Windows executables, SSL.log for SSL transactions, X509 for X509 certificates that were observed. The way you can look at these is they are tab-separated values by default, and up towards the top there is a fields line that has a list of all of the fields. Now, I will be the first to admit that this is not that human readable. Right? I told you it was going to be human readable, and I don't advocate for reading TSV files. You can actually, there's a command that you can use to tell Zeek, output these files in JSON, and then you can run them through JQ, like our friend from a couple of talks ago showed, right, where you can pull out specific fields that you want. But there are tools built into Zeek to help with this problem. So if I cat the con log into zeek-cut, then I can specify fields that I want it to return and get rid of everything else. So if I want the id.origh, which is the origin host or source IP, and the responding host, right, RESPH, responding host or destination IP, and the responding port, I can get those things by just specifying those things, specify them in the order that I want them, orig host, responding host, and responding port, and it will give me that data, and then, right, do all our Unixy things. We can sort this, and then we can do unique-c, and I can see how many times each of these things happen, and then I can go look and say sort-n, right? And the most common thing that happens in my environment is that this source IP of 10.0.0.45 reaches out to 8.8.8.8 on port 53. That's the most common thing happening in my environment. If I want the least common thing, I can, of course, sort in reverse order and get it that way. Now, what this allows us to do then is to get into some of these other things that we want, like let's try and figure out what is the least common HTTP method that has been used in our environment. So we can cat the HTTP log, again, into zeek-cut, and I can get the method, right? That's the field that it's in. We can see that there are a lot of gets. We do all our things again, right? We sort, we unique it with count, and now I can see that far and away, the vast majority of requests in my network that are HTTP are GET requests. There's a small handful of head and options, and then a slightly larger number of posts. And then there's 143 transactions for which there was no method, which might have been, it looked like HTTP, but the server didn't respond, actually. And so the client didn't get far enough to do what they wanted to do, right? That sort of thing. Now, this is working at the command line. If you're trying to analyze a PCAP, one of the things you can do is actually use ZUI or ZUI, which comes from Brim. This is freely available on the internet, and you can literally just, the way you process PCAPs is you open it up and you drag one in. So I'm going to drag one in just so we get the idea, right? I have one that's already processed. This one's going to take 30, 45 seconds. It will run Zeek and Suricata against that PCAP, and it will give you the logs. So if we jump into we have 728 select. This is a PCAP that I already processed earlier, and I grab query pool. What this will do is take us into the logs, and this is a lot easier to start working with because it is giving you everything broken out by field, right? Very JSON-like, and you can do things like, oh, I don't care about this geo.yahoo.com. I can say filter that out, and now I'm in HTTP, and all those are gone, and I can start looking at other things. Or I can expand over here, and I can say I want to group on the host, for example. I want to count by host and see what are common hosts in my traffic and what are uncommon hosts, right? So I recommend using this to explore PCAPs. And then if you want to get into live traffic monitoring with Zeek, you want to run it sort of in the background on a machine that you're feeding traffic into. The way you can do that is getting to where Zeek is located. It's in user local Zeek. If you install it by default, that's where it is. And then there's this etc directory here, which has things like node.config in it. And this is where you can configure a Zeek cluster. This is the default setup is for a single node cluster. Essentially, you're not spreading the work across multiple machines. It's all happening on one machine. And you can just use Zeek control to run that, and it would be Zeek control deploy to run that on your machine. I'm not going to do that here because I'm running it inside of that container, and I'm not sure that it's going to work. But you can run Zeek in real time. One of the things you'll want to do is set it to spit out the logs in JSON format. And then I recommend using something like vector.dev. I have to get back to my old directory. And you can use something like vector.dev, which is an open source tool that is similar to Logstash in that it can read from multiple sources, it can perform transformations on the data, and then it has lots of shippers, they call them syncs, to send data out into many different destinations. And for example, here's like a very bare bones read Zeek logs from JSON, remove them if they haven't been written to for 10 minutes, and send the data out to Splunk via Hack, for example. That's what you want to do if you want to do live traffic analysis and you want to have it in something else like Splunk or like Elasticsearch.
I also saw that you can make an artifact for Velociraptor and import them into there. If anyone's familiar with that.
Oh, the note was you can make an artifact for Velociraptor, like to send these logs into what's the?
Export this JSON and use LogWatch and pull them in. I was curious, so I found someone wrote a small blog post about how they were doing it.
To get the logs into Velociraptor?
Yeah.
Oh, okay, so that you could do all of your analysis there.
Yeah.
That's cool. I haven't played with Velociraptor very much, but that's neat to be able to pull in external data, right? It's going to be giving you telemetry from the endpoints, and then you can pull in something like Zeek and then have it all in one place versus shipping your Velociraptor logs off to Elasticsearch and shipping your Zeek logs to Elasticsearch as well and things like that. Cool, cool. All right. And then I would go into Splunk and start running queries there too. I know it's kind of like Splunk is not an open source tool, but developer licenses are free, and it's an easy tool to use. And it.
I'd use Velociraptor over Splunk,
Okay, I'll have to try it out.
because Velociraptor natively uses Zeek logs.
Awesome. Velociraptor natively uses Zeek logs, and we have at least 2 people in the audience that are very. Okay, we got 3. I'm sold. I have to try it out. It's been on my list of things to do for a long time, but I haven't done it. Any questions?
Yeah, with TLS traffic, like TLS 1.3, it doesn't use SNI, so it's hard to extract like FUDNs and domain names. Have you had any success with Zeek or something similar to get people are going to on TLS 1.3?
This is a very common question that we always seem to get, is that, with TLS 1.3 becoming more and more the norm, there's lots of traffic is encrypted, and TLS 1.3 in particular has more things to prevent sniffing and snooping, right? Like SNI, I think you can still have an SNI. You're not required to, right? You can use encrypted SNI, but it is an extra step for the client. And what we see is actually there is still plenty of TLS 1.3 traffic where they don't use encrypted SNI. And so it's still there. And even if somebody does use encrypted SNI, the next place that I go to look is DNS, because you might make a connection to Pornhub.com, right? And you might use an encrypted SNI, so I can't see it in your TLS traffic, but you might. 300 milliseconds ago, you might have made a DNS query to ask where is Pornhub.com and gotten the IP address, and I can just go stitch those back together. The answer to that, of course, the next question is, well, what about DOH or DOT? And a lot of clients are starting to move towards using DNS over HTTPS or DNS over TLS, and pretty much always there is a way to disable that too. So if you're running the network, you can, for example, Firefox has a KB article, you go get the they call it a canary domain. You put that canary domain in your DNS that you're hosting on your network and black hole that domain. And then all the Firefox clients on your network will try to check for that domain. They will get no response, and then they will fall back to regular DNS, for example. So there's still lots of tricks to do that, to get some visibility. There's still plenty of visibility there. And the other thing I always say to people is, you would be surprised when you look how much stuff you see that is still not even encrypted at all, like not even TLS. A new malware author is born every day, right? So they have to learn their lessons the hard way, and some of those are going to be getting caught not using encryption the first few times. Any other questions?
What's the dumbest thing you've ever seen in the Black Hat knock?
Oh gosh, I can't.
Not in the knock. Detected in the knock.
Detected in the knock, yes, of course. What is the dumbest thing I've ever seen in the Black Hat knock? I will tell you that I cannot tell you now, if I think I'm being recorded, what the dumbest thing is. The lawyers were involved. But if you come downstairs and you find me, I can tell you what the dumbest thing is that I've seen. But I can tell you other things. Usually what we see are people self-hosting things and then logging into them, not realizing that they're not encrypted. Like, we had at least 2, maybe 3 attendees that were self-hosting email, like just stood up an email server on an AWS EC2 instance and SMTP in the clear. You could see him like forward an email to his wife on the same server. Everything's private except for the fact that, like, here's a PDF of your vacation plans. Like it's stuff like that, or like a company, somebody stood up a GitLab instance and didn't put a certificate on it, but they moved it to a high port, so you don't know it's there. But then when they log into it with their enterprise credentials in the clear, HTTP. Yeah, stuff like that. But I have more war stories.
You're the reason why I don't trust my users. Like these stories are the reason why I don't trust my users.
Yeah, and that's why you look at your traffic too, right? Set up the mail server and then look at your traffic. Anybody else? All right. Well, if you have any other questions about using Zeek, or if you want to come ask me what from my super secret war stories, you can find me downstairs. I'll probably be at the Corelight booth, and we have some posters there with Zeek log cheat sheets as well. So nice poster size, like Zeek logs with the fields and the descriptions. Something to hang up on your walls. So thank you all for having me.
Well, one more round of applause.